Hello to viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about edge computing. So let's dive deep into it. So the first thing you will think about is before edge is like what's the difference between edge and a cloud? Well, cloud many times because we do use it often, we kind of forget that it's not actually the clouds. So it's actually just a remote compute and storage that you have access over worldwide net. What does that mean from a company's point of view? Well, it simply means it requires a lot of bandwidth. For example, if you're running just a cement plant, nothing fancy, it could have hundreds of sensors to millions of sensors. And I'm not exaggerating. Yes, there are that many sensors in modern system. Now, let's say you just want to send all the data. You just want to do AI crunching on a hypercluster. You have to send all the data. Bandwidth requirement would be bonkers. Let's just put it that way. It would be bonkers. So that itself is a problem. Now, let's say you are in a situation where you can take care of the bandwidth part. Maybe you cannot take care of the latency part because latency, as Thanos said, is inevitable and it's very disliked. Nobody likes latency. And it's law of physics based. There is a law, physics police came and say that, like, thou shall not cross the speed of light. So you can't cross the speed of light. So fundamentally, even if you have like very good access with fiber and all that jazz, fundamentally it will take time and you can't do anything about it. So it would be in your best interest to have things as close to you as possible, because light speed, while super duper fast, not really instant. So that's another limitation. And not all physical location. Let's say you are in some physical location where you're building your factory or production line or shipping system and all that jazz. You may not have just the luxury of having access for low latency and high bandwidth, because latency is directly dependent on DNS. Where is that DNS? Like, is it close to you? Is it like a physical fiber? When the undersea fiber terminates, it does not terminate to any company, generally terminates into a national asset. That national asset distributes it to the other providers. So how far are you from that? Like, physically, how far are you? That will directly define how good of a quality of internet you can get. But let's say it's fundamentally very far away, you're going to get crappy internet. You can't do anything about it. Now, again, if you are latency sensitive, that's just like nope. That's just nope. And for many people, bandwidth is just like nope, no. So this is why we cannot just, why don't you use cloud? That's the whole point. So we, humanity was growing with internet. We started with CDN, Content Delivery Network. Now, this is basically as advent of large video files became a thing. YouTube became a thing, Netflix became a thing, Amazon Prime became a thing, and Disney Plus became a thing. People started to create CDN, Content Delivery Networks. Now, the idea of Content Delivery Network is that you have your master repository, your original server, so to say. Now, original server will have bandwidth, right? Fiber bandwidth limitation. Now, let's say the fiber bandwidth limitation was 1 terabyte per second, which is quite optimum. But here's the deal. You exported your software, firmware, everything started to go out, and you started collecting users. That's awesome. Everything is fine. Everything is dandy. But here's the deal. Now you're randomly noticing, like, let's say India is like consuming so much of it that you are about to exceed your 1 Tbps limitation. Then what the hell you're supposed to? You can buy more, but again, 1 Tbps connections are not cheap. So you cannot just like, hey, can you add 10 more? No, they will be like, bro, you have to add 1 Tbps more. So at that point in time, you built a cache server. This is a Netflix cache server. Now be mindful, these are old server photos. That's why you can see it. Now I don't think they use something as colorful as this. So cache servers will be put in your country or place where it's closest to you physically, and they will have a small link between the original server and cache server. And cache server will be utilizing all the history data, where it's like, okay, let's say Netflix has 10,000 series, only 1,000 would be mostly viewed, and only 500 would be like, let's say, used in Indian region. So they're like, let's just put all those 500 into the system, and if some customer requests something that is like, not in cache, then it will go to original server. Benefit, the link between these two servers goes down drastically. The load on this linkage goes down drastically. Link on the original server goes down even more drastically. So everybody wins. So you generally try your best to load up local and relevant file. And even if you look into any website, let's say DJI, you go into shopping website, you press Ctrl+Shift+I, inspection video, you will see a lot of CDN reference where like images are actually not loaded on the web page, it's loaded on content delivery network. That's why if you directly try to save a modern website, you don't actually get many images. The images are content delivery network. So that's how we do it. Now, benefit of that is cheaper, quicker for all users, because again, your file, like physical file, does not have to travel very far away. The fiber link length is exponentially smaller. Rather than going from, let's say, India to USA, it's just like, hey, India maybe it could send the let's say user verification or user approval and all that jazz into the original server, which is a very minute file size, and then it's gonna like, okay, it's gonna tell the cache server, it's like, yeah, dump file. So it's surprisingly cheap, surprisingly quicker and effective. Majority of modern world is running on CDN. Like I was genuinely shocked. Like images, I used to think like you will just put your images in that basically, on the actual website. But like, no, I have no idea why, but I think way too many sites have way too many images and all that just, so I think the file requirement is reaching that bandwidth limitation of the original server. So maybe something like that. But CDNs are relatively straightforward. Now, I know every person who is like works on CDN is going to fire missile at me, but yes, it's relatively simpler compared to edge system, because this is just file delivery. You can just deliver your file, be it image, be it video, or be it a text file, or be it a database. It's just for delivery. It does not do crunching on it. It does not take your system and crunch on it. It's just for delivery. That's why DN, delivery network. And generally, it's best used for heavy stuff. Then we come to the edge computing part. Now, edge computation, it's in the name. It is almost like CDN, but it includes computation. You crunch the data. For example, in banking, you require generally serious amount of crunching to authenticate something. Basically, do something with numbers in order to justify whether this transaction is valid or not. Now, that is computationally intensive. Can you do CDN on that? Hell no. So, you need a direct link to the basically headquarter, or you will be like, hey, let's just put an edge server node there. Now, it's generally based on site and processes. What the heck do you want to do? But in some scenarios, you could be like, hey, on site, I want to process it. For example, let's say you are running a factory. Factories have a headquarter. Let's say somewhere in Seattle, they have a headquarter and they want to build a farm in basically Louisiana or whatever have you. And you're like, hey, it has this. I want to do crunch on that. Do you send it to headquarter? Question is, do you need to send it to? Most times answer would be no, you don't actually need to. So you will do as much computation as possible on site. You do as much crunching as possible on site. You get as many things possible done on site. Then you send the base data to the headquarter. Basically, headquarter only gets the report that it actually needs. Other than that, nothing else. It's just like, hey, give me the actual raw, let's say, power consumption, production output, and all. Like, business chart kind of people. They're like, they get the data rather than getting the whole bandwidth needed for collecting all the data, managing all the data, then running all the equipments and all that. It's like, no. Just give us the what matters to us. It's almost like how you have banks when you have clerks who are actually doing the work. Then you have managers. Then you have branch managers. Something similar. So some can be regional also. When I'm talking about node-based or edge can be free floating. For example, edge could be literally in your factory, or edge could be basically a regional. For finance sector, generally is regional. Banking sector is regional, meaning they will have all the data going into the server that is closest to them and then getting crunched, and then the file will be delivered to the user or authenticator in this case. So apps have to be built for this. Be mindful. This is not just like call file from here. It is like you have to be, the structure has to be aware of it, because many times there could be two steps to it. Basically, most of the requests, let's say, is, hey, more than good enough to do it from, let's say, edge node. But what if it needs to push through it? What if the requirement, like same way in CDN, what if it's like, hey, it's requesting a file where it's like, hey, it's not cached on the server. It cannot send a negative request. It has to send it to upper head. So software have to be built for that. It cannot be just like, hey, I put an edge, all problem solved. Do you have a requirement where you may need to push past it? Do you have a procedure, software, all those jazz taken care of in order to do that? You can just do all these things. And there is a worst case scenario. If somebody inexperienced does this, what they will do, like, is the easiest thing to sell to a customer, as in like just, hey, this is a, let's say, Amazon web server. You are doing your compute there. This is Amazon web server's hardware, right? They have this hardware they are giving you. Yeah, let's just buy one of it and put it there. You can do that, and people do that. And there is some utilization to that if you need that redundancy, but you are paying for redundancy. So, and redundancy is generally not desirable unless you need it. For backups, awesome. For other things, not really. So it's up to them. Again, you may be like, hey, I want a 99.99999% uptime. You may be like, hey, let's just pay for redundancy. And in those scenarios, if something bad happens or something weird happens, you may be like, hey, we still have a backup. At least one of those links would be working. So this is what is the difference between CDN and basically edge. Edge is computation. You crunch the numbers. So what about AI? Now, AIs are generally the AIs that are getting all the attention. They are generally hypercluster AIs, meaning the physical oomph they need to run, those are brutal, bonkers. Like, and not everybody just lives next to Amazon, not even Amazon, I'm talking about Microsoft's Azure hyperclusters. Hyperclusters are few and far between. There are many servers, but there are not that many hyperclusters. They are idiotically expensive, like ludicrously, stupendously expensive. And the likelihood of you being just next to one, or to be more precise, next to the one that is running the AI that you need it to run, yeah, good luck with that. So that's the whole point. And many tasks are time sensitive. For example, let's say you are driving autopilot car in a city that has hypercluster. Okay, you may do some computation through that hypercluster, but what if you are in a different city? Then it's like, no, no, latency alone would be make it lethal. So fundamentally, many things are time sensitive. Let's say you are working in robotics. Many robotics do require a lot of AI system, but they cannot tolerate latency. Drone swarms, they do not tolerate latency. So warehouse robotics, for example, let's say you have a conveyor belt, it's random things are coming out. The AI has to do a vision analysis and then select the object, dump it into another box. If you do hypercluster thing, it will work perfectly. That's the good part. Bad part would be it will be so slow that you have to slow down your conveyor belt so vision pipeline does not get overwhelmed. So these things are very serious limitations. So you have to design for it. And there are many ways of solving this issue. For example, you can pre-process the data. For example, let's say you are having a very wide angle camera view, right? Or robotic is working there. You have a wide angle camera view and a lot of things are coming out. But all the main camera compute unit, basically something like this, will do on-site. It's like on-site is just gonna figure it out as like these are static objects. I will not send this to the mothership, and then all I'm gonna do is crop out the object. All it will do is like object analysis, which could be far more robust, far more like, no, I say this is object, that means it's an object. And then it's like, okay, this is object, send the data to the cluster, benefit, smaller file, and less bandwidth requirement. It will go there. AI will like, AI does not need to compute a whole frame. It's just like, oh, this is what it is. This is the object. Now let's focus on the object, and it's like, then robot gets the command. That is what we call pre-processing. So you can pre-process the data. For example, if let's say a headquarter wants the control over the equipments of let's say hydro dam or plant of any sort of manufacturing system, so they will not directly get the SCADA system level access, but they will their edge computing would be there. Benefit of that is like edge computer can take care of situation, meaning it will know itself, hey, the pressure here is getting too serious. I'm going to cut it off. Then I'm going to ping the main system rather than waiting for oh, pressure is high. Let me send a message to the headquarter, and by the time it came, message from headquarter came back, it went boom. So you do not want that. So pre-processing many times is desirable, or sometimes you can just like put the whole thing there. If you can afford it, you might as well put it there. So full processing of data can be done, and this only generated data would be sent out. For example, you are doing all the crunching and all you are sending is a report, so to say, report to the headquarter. And benefit of the hypercluster on the headquarter, they can refine like what is this year's projection, growth, all that jazz. So this is one way of doing with it. So two primary way: A, you take care of most work, or B, you actually do the whole work. That's how the edge works. However, there is one caveat, condition applied, so to say. Hardwares are generally limited by two core vectors here. The vector is cost and power envelope, meaning if you have to pay for the basically headquarter, you're not gonna pay again for the same headquarter. It's inefficient financially, and money systems are very financially sensitive. So you're like, no, we cannot just burn money on buying multiple hyperclusters. So costs are generally very, very tight. So you have to be very efficient with it. And then we come to power envelope. For example, your drone. Let's say you have a drone fleet and you want to do some fancy system with drones. Do you want to use AI? Yes. Okay, awesome. Where do you want to do the compute? It has to be done on the ground. It cannot be done on the robots, simply because you can do that. You can have AI compute hardware, not only the hardware and all the associates, but the power drop would be so bad that instead of 20 minutes of flying time, you will get, let's say, 10 minutes of flying time. Is that sufficient? Then do it. If it's not sufficient, do something on the ground, but it has to be on site so it can reduce the latency. So these all things needs to be figured out properly before you deploy it. Edge is not some buzzword, like how AI has become a buzzword, where it's like everybody says, this has AI. It's like, what does it actually do? No, this has AI. It's like, what does it actually do? Same with edge here. Like you have to know before you add this buzzword, edge. Is it actually doing something? Because you will see like that we have light bulbs that calls home for no reason. Like there is no reason. There should not be a reason. There should be an edge node in your home that should be acting it. And then if you want to compromise your privacy, then you would be like, hey, okay, I'm sending the data to the mothership. So be mindful. Cost and power envelope are the serious limitation. So all these things paints a very clear picture here. It's WIP, meaning work in progress. Do not, at this point in time, when we are talking about in 2023, CDN is a mature technology. Like you got this. Like people are studying this, people have been delivering with this, people have deployed it, we have experienced data, we got this. CDN, we got this. Edge system is very early on. It's in very undercooked phase. So is the idea useful? Absolutely. Idea is like short up, take money. Idea is awesome. However, implementation is based on the project. If you implement it well right now, you're awesome. You're going to enjoy, you're going to have smooth ride, everybody's going to be happy. But you do not do that, you will be like, hey, I thought this edge will make things better, but it ends up costing you more time, more latency because it has to now double check everything. Those things have to be thoroughly taken care of. And it's not as simple as CDN. I know CDN people will fire missiles at me, but again, CDN is a younger brother of basically edge computer. And AI wise, AI is one of those things that it needs far more time to cook. Yes, AI made such a hyper flashes, like you forgot that it actually works on hypercluster. It's not something that you can put in your mobile phone. Like I'll give you a simple example. Other than Samsung mobile phone, I do not know of either Google's Assistant or Apple Siri to actually work on the system. It requires you to send, like you can send, hey, turn on the flashlight. Samsung will do that because they have a voice system, the edge computing built into your mobile phone. Now they have, Google and Apple actually have some compute there only, but I don't think they use it that way. So even if you have to like, hey, can you set up an alarm for like, let's say 5 p.m. Or AM, they'll like, bro, I have to send it to the mothership. It's like, why? Compute. You should be like, there should be like one where it's like, this is a simple request. I can locally fulfill it. Let's just fulfill it. This also reduces cost on their end, because if every request is going to them, and they have to keep increasing their server bandwidth so they can absorb it. It's inefficient. So it should not be like, hey, set a reminder for this. That should not need to go to the headquarters. So it needs more time to cook. And especially for low power hardware, this is another reason why you do not have quality voice system as of now. Can we do really good voice AI where you can actually talk to the AI and AI can actually dictate it properly? No. And low power? No. Flat out no. And this part really needs time to cook. And I'm genuinely shocked that Google has not figured it out, because it has the biggest library known to man, known as YouTube. It's like, bro, use. And how do we gonna solve the hardware part of it? Because be mindful, like software is not magic, it needs to run on something. So there are two contenders that are coming out in the market as of now. One is FPGA. The benefit of FPGA is if you are dealing with something dynamic, which again, if you are utilizing AI, you're supposed to be running on something dynamic. So FPGAs give you dynamic flexibility, meaning if you are adjusting something, the hardware can literally change its physical structure to physically improve the electrical path and be like lower latency, better, efficient, awesome. Or you can have ASICs, for example, let's say a camera chip that is doing object detection. That's a known system. If you know you're going to sell, let's say 10,000 of them, why bother with FPGA? Use ASICs. ASICs will consume less power. It will be even cheaper if you are mass producing it. But many times you may be like, hey, let's just put two of these together. I know most of my things will be done by, ASICs, application specific integrated circuit. But some things will be like, you know what, let's just put some horsepower on tap. For example, Intel's news work series lineups, they generally have FPGA units built into them. The reason is the same. ASICs will take care of 90% of your work, but just in case, let's say you just want to try this random encryption key, you have a hardware where you can configure it and do it on hardware level. So low latency, everything. But FPGAs are more expensive. So these things become a balancing act. And software stack, this is the most critical aspect. It has to be rebuilt from ground up. You cannot just use your old system. And it's not as simple as just calling a file. It is a compute. And you may have a scenario where you have to compute through the mothership. So fundamentally, it's a bit more integrated, bit more complex, so to say. So right now, as of now, when I'm making this in 2023, Edge has not reached the same maturity as people think, but it is a very important technology, and more people are working on it. Software stacks have been deployed, so it's under cooking at this point in time. So this was my presentation on edge computing. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it with a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.